You boot up an older PC with an Ubuntu Server 24.04 USB drive, run through the initial setup, and start the installation. But right as it hits the Extract Auto Install step, the progress bar stops. The system freezes. Hours pass and nothing happens. A quick search online often points to a single explanation. The graphical installer is too heavy for older hardware. Common advice suggests aging processors, like a 6th-generation Skylake i3, lack power for modern deployments. The 6th-gen processor remains idle, waiting for cycles that never arrive. A hardware failure elsewhere on the motherboard consumes every available process, leaving the CPU unable to advance the installation. Misdiagnosing this bottleneck leads to reliable hardware being sent to the scrap heap. To find the cause, we must bypass the frozen installer and examine the raw terminal logs. Pressing Ctrl, Alt, and F2 drops us into the background system console. The terminal reveals a system load average exceeding 4.0, indicating the CPU is attempting to handle more tasks than it can physically process at once. We need to check the system's interrupt requests. This log tracks how frequently hardware components signal the CPU to pause its current task and handle a specific event. The proc/interrupts file reveals massive activity on one specific line. One hardware address is sending thousands of requests to the CPU every second. This line belongs to the PCIe Advanced Error Reporting mechanism, or AER. The internal Wi-Fi module is triggering this mechanism, generating a continuous stream of error reports across the data bus. These are correctable electrical errors. While the hardware remains functional, the CPU must stop the Ubuntu installation to acknowledge and dismiss every single warning. A malfunctioning network card is flooding the system with these high-priority warnings, starving the installation of the processing cycles it needs to finish. To complete the installation, we must instruct the operating system to ignore these specific hardware errors. Reboot the machine from the installation USB. When the boot menu appears, press E to open the configuration editor. Locate the line beginning with Linux and carefully move to the end. Type PCI equals no AER just before the 3 dashes. This parameter disables the AER handler during the boot process. Press Ctrl X to boot. The system now ignores the signals from the Wi-Fi card. The processor focuses on the installer, allowing the setup to finish. This bypass allows the operating system to install to your drive. However, this is only a temporary configuration for the installation phase, and it will not persist after the next restart. Once the installed system boots, it may seem stable. Ubuntu Server typically leaves Wi-Fi hardware deactivated by default, so the error storm remains dormant. We can verify the Wi-Fi card is the cause by intentionally activating the hardware and monitoring the system response in real time. Using the command sudo ip-link set WLP1S0 up forces the network interface to become active. As the card attempts to scan for a signal, the electrical loop triggers. Interrupt requests immediately spike to over 80,000 per second. Deactivating the interface does not resolve the issue. The physical hardware continues to receive power, and the error loop persists as long as the driver is active in the kernel. Since the hardware is flawed, stability requires a software configuration that prevents the operating system from communicating with this specific microchip. We solve this by blacklisting the driver. This prevents the operating system from loading the software needed to interact with the broken Wi-Fi hardware. In the terminal, use this command to add blacklist RTL8723BE to a new configuration file within the /etc/modprobe.d directory. Run sudo update initramf-u to update the startup files, then reboot the machine. This configuration stops the driver from loading at boot. The hardware defect is neutralized without needing to physically disassemble the computer. With the machine now using a wired Ethernet connection, the load average drops to near zero. The system is stable and ready for 24/7 operation. When a system freezes during installation, the age of the processor is often a distraction. A 6th-generation i3 remains a capable server chip once hardware-level bottlenecks are identified. Terminal logs and interrupt monitors provide the specific data needed to identify these failures. They allow you to see exactly how the hardware is interacting with the kernel. By identifying these diagnostic details,
you can rescue hardware from being discarded and repurpose it for server architecture. If you've encountered similar PCIe errors, share your findings in the comments below.